You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey everyone, I am so excited about our conversation today. The topic is a memory-safe future to space and beyond. I'm very interested in the space part of this, but I want to first just give a little overview of what we're talking about today. The White House wants all of us to be memory safe by thinking in some respects of governing through engineering. It's a shift that's unprecedented in how we think of software, defining how we govern. And this is fascinating to me. It involves looking at what is effective as we think of security from a societal perspective. And to discuss this, I'm joined by Anil Dash, Vice President of Developer Experience at Fastly. Anil described himself on his blog as a tech entrepreneur and writer and someone who's trying to make technology more responsible. He's been creating internet technologies for 2 decades and writing on his blog the whole time, focused on ensuring that technology's transformative impact on society, media, the arts, labor, government, and culture is as positive as possible. I borrowed that from Anil's site, but Anil, it really strikes me as interesting as your background and what we're discussing today, because it brings in the context of technology as a positive. And what we find today is in this place where this report from the White House advocates a future for memory safe software, which is quite positive in my respects. I'm wondering what you think about this idea of engineering first.
I think it's pretty exciting. If it's useful, I might go into a little bit of background and sort of what informs my lens on this and sort of what my work is. And so, as you mentioned, I'm at Fastly. We've built a platform that is this instant global programmable network, right? The thing we're best known for is the content delivery, but all of it is this idea that using software, you can control everything between you and your user, and that the thing that we are sort of uniquely good at is making that instant, right? So whether that's retrieving the data, delivering the data, computing, whatever we're doing. And part of it is, in order to be trustworthy and reliable in doing that, we had to invest a lot in making a safe environment for code to run. Otherwise, if you're, for example, sending a message to 1 billion people around the internet, that's something that can be, have a negative impact on people's experience if it's not protected, or if there are not bounds on that are ensuring that the code that's running is safe. So and in particular, the technology that we invested a lot in helping to enable as part of the open source community is WebAssembly, which is one of the technologies I'm sure we'll talk a lot about today. And so we think of it as like, in addition to building the tooling and the technology, can we be providing killer apps for that new memory safe world of WebAssembly? And then my personal experiences, I've been a coder pretty much my whole life, but had worked as an advisor on digital strategy and public policy, under the Obama administration, and also just in broader public policy conversations around this stuff. And there's an idea that, like, I think is often invisible in technology, which is that good regulation, good policy making can really drive innovation. The thing I think of is, like, it's actually pretty remarkable that you pull out your phone, you go to a coffee shop, and it just connects to the Wi-Fi.
Yeah.
And that is, amongst many other things and technological innovations, all these other things, a triumph of great policy making. Because we don't have 10 different competing, what brand phone do you have? And what brand of Wi-Fi do we have at this coffee shop? And do they work together? And do you have to pay extra for it to go? All these different things. That is because we had good spectrum policy and sort of good regulation there. And there's a million more examples, but that's the one that jumps out to me of like so many things in infrastructure, when it works right, you don't even notice it. And so I think about that, where we don't as consumers or end users, if we're not putting on an engineering hat, we don't often see the cost of, like, these technologies were not safe by default, that we had an out of bounds memory error, or we had a memory protection error. Every developer knows these things. Like I helped in the early days of starting up Stack Overflow, and then was on the board for 10 plus years. So very involved with the company. But when we were working on picking the name, I was talking to Jeff Atwood, the co-founder, and part of it was like, okay, what's a name that we could pick for this developer community? It became the largest developer community in the world that all of them would know. And it's no surprise that the very name of the largest developer community that's ever been created is about an error that has to do with lack of safety in coding, which is Stack Overflow, right? And so like it's that intrinsic to the culture that you can use it as like a shibboleth, as a signal of like you're in the group. Like you're one of us if you know this kind of bug, right? And so that's like the original sin of coding software, going back 75 years. Like the first computers had this class of bug, this class of problem. And so what would it take to change the entire environment to where code is safe by default? Yes, it's technology innovation. Yes, it's tooling. Yes, it's, like there's all this sort of list of things that has to happen. But absolutely a fundamental part of it is good, smart policy making that sets, really wise defaults. And so I think this is like a best case scenario, a best of both worlds, where like we're getting at the same time as the technology is maturing, the policy making is maturing to be ready for that.
It's interesting because you think about where we are today, and we have open source, right? And open source really made all these programming languages possible. Now we're increasingly moving into an era of open knowledge. Kelsey Hightower brought this up recently at a conference.
Yeah.
And so it's almost like open source is a subset of open knowledge. And because in a much greater scheme, you're thinking about open knowledge as really the way that we can all, as a society, continue to, hopefully prosper, right?
Yeah.
And WebAssembly is a part of that, and what I like about what you said is you bring up the heritage of language, the heritage of technology. And that's what really strikes me, because if you look at this, let me just share my screen here. And it's a chart I made essentially with an LLM, right? So of course, but it just shows the ability to use technology effectively. But in any case, what we're looking at is programming language safety. And what we're looking at is memory safe programming languages and not memory safe programming languages. What really strikes me about this is how all of these not memory safe programming languages actually can still be usable with new open source technologies such as WebAssembly, correct?
Yeah. And I think the thing is, just to sort of backtrack a little bit, there's this idea of memory safety, which is really key. And I think is like I said, one of the most common classes of bugs. Like if you take what has consistently been a cause of fundamental like crash level bugs over, like I said, the last 75 years, you're going to have memory safety in the top 10 the entire time, probably top 5 entire time. And that's rare, right? Think of how much software programming has changed since punch cards and all that kind of stuff. And like to be like, nope, this is still the our nemesis. This is like the Joker to the Batman of these last 3/4 of a century.
Yeah.
And so I think what's interesting about that is like that's just one of the techniques, right? There's other things you do towards safety, which is like I said, coding practices, everything else. But the challenge of that was so well understood that when all of these languages were being created, and most of these are, in that more than 20-year time frame, right? Java was in the 90s, C# was in the 90s. Like, these are languages that have been around for a long time. I think the only sort of newer ones on here are Swift, Kotlin, TypeScript kind of stuff. And the reason that these languages, even that far back, 20, 30 years ago, were being created with the mind to this is because everybody knew we were headed towards this future. There's no lack of awareness that this is something we needed to address. And so they were designed in anticipation of we should all be trying to solve this kind of problem. And then they're almost waiting for the moment we're in now, where it's actually realistic to say, like this is the work I do. I lead our edge computing platform at Fastly. And the thing people want to use the platform to is to instantly deploy code around the world that's running for, maybe hundreds of millions or billions of users. And now you can do that and have it be safe. And that's something that wasn't true 10 years ago. It wasn't true 20 years ago. And yet the languages work with it. Like people use
Right.
Rust to do that, or they use, TypeScript to do that, or Go, or whatever it is. They're using the language they love that didn't have to change to enable that, because it was built in anticipation that one day that kind of platform could exist. And so I think there's a little bit of like, this is, the moment we've been waiting for 10, 20, 30, 50 years.
Yeah. Yeah, it is it's an important moment, and it also speaks to the readiness in society for this shift. For when the White House comes forward, they're not going to be the first one to come forward on matters
Right.
such as this. They're going to be the ones who are going to say, hey, society is definitely moving in this direction. We need to think about this. And so it seems to me that this is an effort to give the enterprises a little nudge, businesses a little nudge, hardware vendors start developing better standards to build by and measurements as gets into this report. I just want to share my screen again to show this report that I'm talking about, because this is kind of the basis for the conversation today. So here's a report from the White House on back to the building blocks, a path towards secure and measurable software. And it gets into all these types of things, where into the memory safe programming languages, but also other matters such as the importance of measurement. One thing that gets to me here is and this is where the WebAssembly story comes into play, I think, is technical debt, and which is so often ignored. I was talking to some technologists at reInvent last year, and they talked about all this kind of talk at reInvent was all about AI, right? AI, as you get at any kind of conference you go to these days. They get on stage, they talk about AI. But then you get into this question of technical debt, and it just gets pushed aside and pushed aside and pushed aside. And this seems to me like a huge issue here, as we're moving forward. And it gets into this further, I think it puts us closer to what I found fascinating in the report when they talked about space exploration. And so they probably have this idea of Rust in space, about, essentially about the ultimate edge. Why do you think they're talking about space in this report, and what do you think it has to do with technical debt?
So there's a couple related things. Both is how does this get made, and then why, right? And the why is actually pretty easy, which is that for all of the space agencies, NASA sort of foremost among them, reliability is the utmost concern. And it's hard to explain, because on the ground we think 2 or 3 or 5 nines is a lot, right? And when you get to space, 13 or 15 nines can be the standard of reliability and accountability, right? And what you're getting into there is not just reliability, but resilience, predictability, and also thinking in many cases over decades. We have missions still active, right, that are decades old, 30 plus years. So that's why you start to care about what sounds esoteric, like, memory safety. Any cause of bugs that endangers a mission that might run after the people creating it are still alive. That's a different lift. And also the fact that you, literally because of, if you're doing planetary exploration, deep space exploration, the alignment that enables you to do that kind of thing might happen literally once in a lifetime. And so the stakes on that stuff is different. The problem solving space is different. And what happens very often for people that are not thinking about public policy, not thinking about shared resources like space, we put it in the context of our own lives, right? Which is well, if it breaks, I'll get another one. You know what I mean? It's a little bit of a different sense of what you're trying to do. The other thing that I think I find, having bounced between the policy world and the traditional tech industry a lot, that's poorly understood for people that haven't done policymaking, is it is literally designed to serve everyone. And that's not everybody with the latest browser. That's not everybody with the latest phone. That's not everybody on the latest OS update. That's not everybody with a high-speed connection. It's everyone.
Everyone.
And think about when you are chasing the difference between 2 nines and 3 nines and 5 nines and all that kind of stuff, that little additional bit of everyone or everything or getting to 100% often takes exponentially more effort.
Sure does.
Right. And so that's, I think, the part that's non-obvious about like, why would they talk about space and why do they talk about Rust in space, which I love. It's such an evocative image, is because the cost of failure is so high. Like, we're not going to get to put that satellite up again. We're not going to get to explore that phenomenon again. We're not going to get the chance to do another launch again, like whatever it is. That raises the stakes so much higher, and it's sort of that much more important. That's the why. We get into the how, and I don't want to get too deep in the weeds, but I think it's kind of important to understand. So this report came out of the Office of the National Cyber Director. These offices used to be called czars until people started freaking out about that politically, right?
Thank goodness we don't use that anymore.
Yeah.
We're still using cyberspace, but I will let that go.
Yeah, I mean, and the jargon lags because it's people that are coming from a different context, right? They're translating to a different world inside the Beltway. But this would have been called like the cybersecurity czar or something. Right. And what it does is it sits inside the executive office of the president, and this is literally the like infrastructure of people that keep these programs running, kind of also without regard to who's in office. Like it's continuity of capability in serving the public good. And so they're really, the thing I say is like incredibly technically fluent, incredibly sincere in their goals, and very obviously not doing it for the money, because you're not going to get some big stock grant going to work in the executive office of the president. You're getting paid federal pay scale. So you have to be a true believer.
Yeah, you do.
This is the kind of thing that I think is not very visible to people outside. It's like there's a real it's the same kind of pure-heartedness you see in somebody who becomes a volunteer firefighter, is what it feels like to me.
Well, it also comes back to that heritage that I mentioned earlier, and I want to read something from the report, and it goes back to kind of this idea of like everything for, this is for everyone, but it also speaks to the heritage of our space exploration and in the history of software. And they write, in April of 1970, an onboard explosion derailed Apollo 13's mission to the moon. 2 days in, the astronauts' voyage, an exposed wire ignited a fire and caused one of the ship's 2 oxygen tanks to burst. The astronauts' only hope for survival was for the rocket scientists to react ingeniously and fast. Employing the laws of physics and the rules of mathematics, the aerospace engineers were quickly and calculated an engine burn by the lunar module to successfully get Apollo 13 on a trajectory back to Earth. And what they do is, and they equate this to software engineering, and the idea that it's actually the people in the command center who are really helping kind of like steer the spacecraft, where in many ways we're talking about memory safe programming language in our world, helping us steer our way through business problems, through all kinds of problems that we face every day.
Yeah, and you think a lot of this is also just about probability. Like, how do you make your odds the best they can be? You're never going to be 100%, but how do you make it the most likely odds you're going to get to the good outcome? And what are the parameters you can control? And this is about sort of giving that space. I think the other thing we're seeing is a much higher degree of fluency in the problem space, in the technical space, right? There are people here that are experts. I draw an analogy here to like this, there's an office in the, that reports to one of the cabinet members called the Office of Science and Technology Policy in the White House. And the Office of Science and Technology Policy does everything from like, what is our strategy for NASA, to interacting with things like the office, the cybersecurity office, the cyber director. And, the level of fluency those folks have, they're industry level experts, right? They're really, really good. And they did a recent sort of similar paper to this that was around the AI Bill of Rights for citizens and consumers. And it's such a different thing because it's framed not in terms of like, latest and greatest AI hype, but like, what are the basics? What are the fundamentals that we should all have consensus on and be working towards? And I think this document has a sort of similar purpose to it, which is like, let's shape the understanding of it, make sure we have consensus on the facts, and we can debate around the edges about what's the best approach and how do you do it and whatever. But I think it's such a different thing than what often happens in the tech industry is this sort of caricature of talking about, those policymakers inside the Beltway, they don't get it and they don't understand tech and they're trying to keep us from innovating. And it's like, this is enabling innovation. If you start from like, okay, how do we define the problem? Do we have consensus about that? Now we can start to think about innovating in ways to solve it. That's a real enabler. And so I think that's something that is non-obvious. Is a level of thought that goes into, did you structure the problem correctly so that everybody can think about ways to solve it?
Mm-hmm. Well, when you think about all these matters, it gets then back to the question of hardware and software, right? Like I think about rockets, like, and what they were, we built this giant rocket so it could go to the moon, and everyone thought like, well, we have a giant rocket, of course we can go to the moon, right? Um,
And meanwhile, the wire that endangered that rocket was probably 10 cents.
10 cents, right? Just as a semicolon may save you millions, right? In code, right? Or the a syntax error can really is some kind of like really derail a software application.
Exactly.
But so the idea of the rocket gets me back to then the hardware question, and this is where it gets a little interesting for me because we need to be able to think about the software, and we have historically been able to do that. But this is an issue that Linus Torvalds brought up at the Open Source Summit in his keynote about the gap between hardware development and software development. In software development, you can you can spin up a new version and put it into production, right? You can't do that in hardware, right? So I'm trying to understand this intersection here, because this is kind of a big problem that we face now, where hardware development is pretty much closed, right? It's not open. And in software development, it's pretty much open and you can update things very quickly.
Yeah. There are some exceptions, I want to call out. There is a lot of movement in the open source hardware world, but I think broadly you're right. And certainly at the like consumer grade mass market systems and chips, like you are not only looking at being proprietary, but more and more integrated. As we record this, Apple just announced a whole bunch of new iPads, and like they could not be more fully integrated, right? Like the chip has got the memory on it, and the chip is from the same manufacturer as the device. Like it's really, really sort of profoundly integrated.
Yeah.
And obviously that's in consumer space, not necessarily like servers where people are running code or infrastructure. But I think that's actually, that's a real constraint. And I think that's one of the things to think about is like, well, how would we solve that problem? What would we require? Like, do we say like because the federal government's a massive procurer of these technologies, do we say that they're going to require some degree of openness, right? So that they can get a second supplier. And part of that's okay, it's great, might bring the cost down and those kinds of stuff, but also so we can inspect it. If we believe that many eyes makes all bugs shallow and all those other sort of tropes that we always go back to, should we be able to examine our hardware infrastructure all the way down to its fundamentals and understand whether it's secure by design?
Yes. And there are exceptions. But it seems like that's such another such a bigger problem, right? I get the whole.
It seems huge, but it seemed insurmountable that we would have large scale deployments of memory safe platforms at one point, and now we do. So, like, I think, big things are possible. Hard problems are solvable. We can make transformations, and some of it is also the impact that good regulations can have in incentivizing the right behavior, right? Again, just using another sort of consumer example, the top app in the App Store for Apple as we record this is a software emulator for old video game console systems. And the reason it's the top app right now is because it was never allowed before. The App Store launched 15 years ago plus, and they were like, this is a category we don't allow. And European regulators said, no, you got to allow this thing. And Apple finally lets it in. And there's so much demand that it's more popular than Instagram, and it's more popular than, Uber. It's more popular than any app on the App Store for people to be able to run an emulator and play old games. And so, one, I just love that because, like, how many of us learned about what machines could do through emulators, emulating video game systems, right? Like this, love this teaching. And ironically, one of the things that it gives you is if you're emulating an old Nintendo system and it's in that emulator, it's more memory safe running in that emulator than it was on the old hardware.
It's interesting because emulators, in some respects, have a kind of a contextual, have some context with WebAssembly.
Yeah, they're process isolation. They're very analogous. I mean, it's actually a thing that's easy for people to understand if they've ever, like I said, if they've ever run an old Nintendo emulator and seen, oh, I can switch between all the different games and play, whatever, Mario and Zelda and all those things.
Right.
You're like, okay, well, this is what we're doing. Like those game discs or cartridges are what we're doing in WebAssembly and putting in. We have people plugging their components into what they're doing on Fastly Compute every day, and I'm like, great, this is you're switching out your game, right? And so I think, but the broader part is regulation made possible innovation and a good user experience and new protected experiences on iOS. And it was pretty painless. Like the app already existed. People have been building this on their sort of homebrew systems for a long time. And so I think that's something where we have these great pent up areas of demand and genuine user need or genuine infrastructural systemic need that can be unlocked relatively easy with good regulation. So in the hardware world, we can imagine a different set of requirements. If you want to sell these devices to, the trillions of dollars that in the US we spend on defense, you have to have some visibility and some understanding and monitorability of the systems. I think that's going to happen in areas like the mobile phone chipsets and especially like 5G and things like that. I think there's a lot of concerns of nation states that have control over the infrastructure we use to do phone signaling and over the infrastructure we use to transmit data in public. And so examinability and inspectability is a national security concern.
Sure,
it just is, right? So if you can monitor every transmission somebody makes on a certain phone frequency, that's a big vulnerability. The right answer to that is open source hardware. So that's not a radical solution. That's a very obvious solution.
It's an obvious solution for sure. And that gives good context for it. One of the things that the report essentially states is that, there are 3 dimensions that we need to think about with the risk that software does pose. They talked about the developer process. They talked about the software analysis and testing, which I don't want to get into right now, and the execution environment. But one thing that they also talk about is metrics and the importance of metrics, which is, I think after you think about it, it really makes sense. And this opens up a lot of new dimensions for helping us understand software and the benefits it offers, but also what we need to be looking at from a visualization perspective. And what intrigues me about it is how this might be intriguing to developers.
Yeah, I mean, I think devs are naturally drawn to anything that's got a new surface area to it, right? What are the things I can probe out here? What are the things I can learn? What are the things I can hack on? I think there's just an intrinsic curiosity that manifests.
Yeah. So the measurement aspects of what they're talking about here, maybe you could help us sum it up. What do you see as the importance of this, of them discussing measurement in a report such as this?
Well, I mean, I think it's a simple anything that's not measured isn't going to improve. I think it's sort of the first part. I think the other part is the measurements give us the ability to have reasonable conversations about it between different practitioners. Because one of the most effective roles that good policymaking can have is to be a convener of a conversation across an industry and between maybe competitive interests. And so, catalyzing the focus on measurements and metrics lets you make sure you're starting from, again, the common fact base. You're having the same conversation. And also there's a good criticality of well, I don't like how you're measuring it, right? Are you putting weight on this part of the system when you should or shouldn't do so? I think those things are really about, like I said, catalyzing the right conversation to happen. And so that's why you focus on measurability. In addition to obviously, does this thing work? It does what it says it does, and are the system goals achieved? All those things are there. But I think, for example, a lot of the model of this is collaboration through open science and open publishing in academia. And one of the reasons you always publish your data when you publish an academic paper so people can reproduce it. So we're aiming towards reproducibility of results in this. And I think metrics are just one aspect of that, but they're a very powerful and important aspect of that.
Right. I think just in conclusion, I think of all of the different threads that weave together, in this discussion. And it brings me back to the current state of the world, right? Where we have AI, where we have open source. We just published a story today or yesterday on open source that are being at a crossroads, right? With the forking of Redis and Terraform, and the question of maintenance of open source projects that are critical to internet infrastructure.
Yep.
And so I'm just, you have a lot of, of insight into this kind of.
Yeah. So, I mean, this is a thing we think about deeply. So at Fastly, we have a program called Fast Forward where we support open source projects. And if you've ever, downloaded a Python package or a Ruby gem or whatever, we probably help deliver that. Or if you've downloaded Kubernetes, that's something that we help sponsor, and we're really proud to do it. It's been, I don't know how many countless trillions of requests that we've delivered on behalf of open source projects. But part of what that does is gives us a visibility into and relationship with the people that are doing this work every day. And what we see is like the reason that we want to support and subsidize and sponsor open source is not just that it's the right thing to do and warm fuzzies. Obviously, some part of it, we're corporations, so we hope that makes you feel good about us and you're going to buy stuff from Fastly, and that's great. But I think there's also a part which is like, let's take the recent XZ vulnerability.
Yeah.
A fundamental cause of that vulnerability was maintainer fatigue.
Yes.
The person in charge of that software was ground down by the thanklessness of maintaining this obscure piece of software at your own expense and cost, for years on end. And all you get in return is some bug reports every once in a while. And so part of what we look at is how do you improve the quality of life for people who create open source? And that's a very real thing we think about in terms of like what Fastly is doing Fast Forward. But I think the entire ecosystem needs to think about that, is like, how do we make sure that people who make the open source are, and it sounds, I don't know, touchy-feely or warm and fuzzies, but like, how do we make sure they're happy and doing well? And it's the right thing to do at a human level, but it also is the right thing to do in terms of improving ecosystem security. And so like, that's a happy thing, right? If we're like taking care of each other is also the way we keep each other safe. That's a wonderful thing, but it also means like we should be asking more. I mean, we're, Fastly's moderately well known in the industry, but we're not like one of the giants. Like there's these multiple trillion-dollar companies that everybody talks about all day, every day. And how do we ask them to do more to make sure that everybody in the ecosystem that they rely on is safe and doing well and building in ways that are safe? I think these things, like the human considerations and the accommodations we make to taking care of each other, are as important as the technology in making sure things are safe, right? If the tech is safe and the people aren't safe, we're not safe anyway. And so I think that's something that we really think about. It's like combining both the systemic technical concerns as well as the like real world human concerns. And if you address both of those, and we definitely strive to, and I think a lot of good teams do, then you have the chance to make a real meaningful dent in the overall amount of risk that everyone on the internet, everyone in the ecosystem is taking.
Well, it's a profound report in many respects for me. It says a lot about how we need to think about technology, but also about society. And I think your last statement reflects that, where a lot of the software industry is based upon the vision that we're here to make the world a better place. And that's a vision that I think is worth upholding, but it often doesn't stand up. And we find ourselves, in situations where it becomes, then it comes down to this common denominator, which is trust.
Mm-hmm.
And that seems to me is like the matter of primary concern right now. Not, and in technology is a symbol, I think, of society in many respects. And that trust matter seems critical right now. I mean, that the Linux XZ is case in point. This guy is exhausted. He's a maintainer. someone exploits them, says, knows that this guy's exhausted and says, you're not doing your job, let me do it, comes in and puts in a backdoor, right?
Yep. Simple as that.
But Anil, I just want to thank you so much for taking the time.
So happy to do it. Thank you for having me. And this is something we care about deeply. What I'd say from our side is like we're all in on this effort. We've, like I said, at Fastly, we've done everything from helping catalyze the WebAssembly ecosystem to building a platform that is secure by design to supporting the open source maintainers and projects that are needed to keep us safe. This is, I'm lucky I get to spend my working hours and waking hours, trying to do better in this effort, but I really, it's going to take all of us. So I think that's the thing I'd sort of say is like, if we can kind of all be joining the movement to keep all of our ecosystem and all our people on the internet safe, then, we can get a lot of incredible work done doing that.
Great. Well, thank you so much.
Thank you.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.